Welcome back to my YouTube channel. Today's LeetCode DCC question is find all people with secret. Let's read the question. You are given an integer n indicating that there are n people numbered from 0 to n minus 1. You are also given a zero index 2D integer array meetings where meetings I is xi, yi, time I, indicating that a person xi and person yi have a meeting at time frame t equal to time I. Person may attend multiple meetings at the same time. And finally, you are also given an integer first person. So what question is saying? We have given n people numbered from 0 to n minus 1, and there is a meeting schedule between this person 1, person 2 in time frame t equal to t. So there are meeting schedules at t equal to t between person 1 and person 2. And there can be, and one more point they are saying that person may attend multiple meetings at the same time. That means if suppose at time frame t equal to 2, there is a meeting between person 1 and person 2, then at the same time, person 1 can also attend a meeting with person 3, and person 2 can also attend a meeting with person 4. That means one person can attend multiple meetings at the same time frame. Now, person 0 has a secret. So, out of all these persons 0 to n minus 1, person 0 is the first person who knows the secret, right? Now, they are saying and initially shares the secret with a first person at time t equal to 0. So, we have given f first person, that is fp, and P0 shares a secret with first person at time equal to 0. That means before any time frame t equal to 1, before t equal to 1, before that person 0 and person FP knows the secret. Now this secret is shared every time a meeting takes place with a person that has the secret. More formally, for every meeting, if a person Xi has a secret at time I, then they will share the secret with person Yi and vice versa. So what they are saying, if there is a meeting between person 1 and person 2 at suppose time frame t equal to t, and before this time frame, suppose person 0 knows the secret and person 1 knows the secret. Now, since there is a meeting between P1 and P2 and P1 knows the secret, that means P1 will pass the message secret to P2. Now, after this time frame, we can say P0, P1 as well as P2 knows the secret. That's what this point is saying. For every meeting, if a person Xi has a secret at time I, then they will share the secret with person I, Yi, and vice versa. Vice versa is saying, even if there was a meeting between P2 and P1, then also P1 will share the secret with P2. Next, they are saying the secrets are shared instantaneously. That is, a person may receive the secret and share it with people in other meetings within the same time frame. For example, Let's suppose initially only A knows the secret. Person A knows the secret. Now, at time frame T, there are several meeting schedules between a person. Let's suppose there is a meeting between A and B, meeting between B and C, meeting between C and D, like this. Now, since A knows the secret, A will pass the message to B instantaneously, and in the same time frame, B can pass the message to C. Similarly, C can pass the message to D. So we can say after time frame T equal to D, A knows the secret, B knows the secret, C knows the secret, as well as D knows the secret. That's what this point was saying. So after all the time frames and all the meeting has been attended, we have to return a list of all the people that have the secret, and we can return the answer in any order. So we have to return the list who knows the secret, and we can return in any order. It's not necessary to be in the ascending order. Now let's see one more point. Suppose initially A knows the secret, right? A knows the secret, and now we have a time frame T equal to T. In this, there is a meeting between B and C. Now, since only A knows the secret and neither B nor C knows the secret, that means after this meeting, still only A will know the secret. Now, suppose in time frame T equal to T plus 1, there is a meeting between A to B. Now, as A knows the secret, A will pass the secret to B. So after this time frame, A and B both will know the secret. So can we say, since there was a meeting between B and C, after this time frame, C will also know the secret? Is this correct? No, this is not. Because before time frame T plus 1, the meeting between B and C was over. Now we can't Now we can't go back and share the secret with that person with whom we have the meeting earlier. So this point is wrong. So after this T equal to T plus 1, still only A and B will know the secret. So now let's see how we can approach the solution. So initially they have given only A will know the secret, right? Only A 0 will know the secret. And at time frame T equal to 0, time frame T equal to 0, A will pass the message to first person. Let's suppose FP. Can we say the ultimate source of secret for first person was 0? Now in future time frame, suppose at T equal to T, if 0, person 0, or this person, first person, shares or pass a message or secret to any other person, person X. So can we say the ultimate source of secret for Px was also 0? Since 0 passed the message to Fp, and now Fp is passing a message to Px. Now if again in future time frame Px passes any message to person Py, so the ultimate source of secret for Py will also be 0. So can we say at the end, if any person, if there is a list of person who knows the secret, then can we say the source of the secret for all this person was zero, person zero? That means at any time frame, there must be a meeting between 0 to some person, 0 or FP to some person. Now, suppose we can say, suppose there are a set of person who knows the secret. In this, 0 is also present and FP is also present. So this person knows the secret. And there are a set of meetings person. Suppose there are a set of person who are somehow, these are a set of person who are somehow linked with the meeting. That means I want to say, suppose there is a person A who has a meeting with person B. There is a person B who has a person with meeting with person C. And there is a person C who has a meeting with person D. Now, all this person don't know the secret. Secret is unknown to them. But now, if in the same time frame, if there is a meeting between any person from this secret group and any person from this unknown group, if there is a meeting, that means can we say all this person will now be known the secret? If that is so, then can we say after time t equal to t, all this person will know the secret? That means after time t equal to t, all this person will come under secret group. Now after this, the secret group will be 0, FP, A, B, C, and D. Now let's take one more scenario. Suppose there are a set of person who knows the secret, and at time t equal to t, there are person who don't know the secret and somehow linked with some of the meetings. For example, A is linked with B, B is linked with C, F is linked with G, like this. Now we can see inside this group also there are two subgroups, this one and this one. So if in this time frame there is no between any person from this secret group and no person from any person from this group, that means after this time frame still only this person will know the secret. Or if there is a meeting between a person from this group and a person from this group, this subgroup, then only this subgroup and this secret group will know the secret. Or if there is a meeting between person from this group and this subgroup, then this subgroup will know the secret. So can we mark this group somehow, like if there is a meeting between a person from this secret group and this subgroup, can we mark this subgroup by any means indicating that all these people now know the secret? Let's see how we can mark it. Now, suppose we have taken an array which will store the ultimate source of secret for this person. Now, initially, 0 for 0, the ultimate source of secret is 0. Now, suppose this is the first person. For this person also, the ultimate source of secret is 0. Now, there are some groups who are, suppose this is a group who have a meeting at time equal to t. And another group, suppose this is another group who have a meeting at time equal to t. Now, if there is a meeting between a person 0 and any person from this group, that means all this person will now knowing the secret. So can we say the ultimate source of secret for this group is also 0? That means, and now suppose if there is a meeting between FP and any person from this group, can we say the ultimate source of secret for this person will be equal to ultimate source of secret of FP? Now, since ultimate source of secret for FP was 0, so the ultimate source of secret for this group will also be 0. That means after completing all the meetings and at the end of the time frame, at last we will see that the ultimate source of secret for all the person. If there are a person whose ultimate source of secrets are 0, that means only those person knows the secret and remaining don't know the secret. So can we utilize this information and can we store this information somehow to obtain the result? So after this, we can return the vector who have the value 0 as the ultimate source of secret. So for this, I think the best data structure which is suitable is disjoint set. So how this will work? Now suppose initially 0 and FP knows the secret. So this comes under one disjoint set. And the ultimate source, or we can say the ultimate parent, like in disjoint set we say parent. So ultimate parent for this FP is 0. So in the array, we can mark, sorry, suppose in the array, we can mark the ultimate source. Suppose for 0, the ultimate source is 0. And suppose this is FP and the ultimate source of secret for FP is also 0. That means can we say the parent of 0 will be 0 and the parent of FP will also be 0? And in future, if any at any time frame, if any person knows the secret, can we mark the ultimate parent for this person as 0? Yes. And initially, we will keep the parent of the respective person as that only. That means the ultimate source of secret for 2 is 2. The ultimate source of secret of 3 is 3, like that. Once a secret has been passed to this person, then the ultimate source will definitely be 0. Then we can change the value to 0. And if there is a meeting between person 1 and person 2, we will see that either of this person has the ultimate source of secret as 0 or not. If they have the ultimate source of secret as 0, if anyone, that means any one person knows the secret and that person will pass the secret to another person and the ultimate source of that person will also become 0. So in this way, we will cluster the person who knows the secret and the ultimate parent of all those cluster will be 0. Or we can say the ultimate source of secret for all those cluster of person will be 0. And the remaining person, we will say the source of secret will be same. Like for A, it will be A. That means A still don't know the secret. one more point. Suppose, suppose we have a meeting like A to B, B to C, and C to D. Now, in this, once we see there is a meeting between A to B, so we will mark the parent of A to A and parent of B to A like this. Now, suppose if there is a meeting between B and C, we will see we will mark the parent of C as the ultimate parent of B. So in this case also the ultimate parent of C will be A. Now suppose this person don't know the secret and there is no meeting between this person and the person who knows the secret. Then in that case you have to revert back this parent. So if after time frame T we see there is no meeting between this person and a person who knows the secret. If there is no such meeting, then we have to revert back all the ultimate parents to itself. So after time frame t equal to t, we have to revert the parent of A to A, B to B, and C to C, like that. So at the end, what we will get, if person P1, P2, P7 knows the secret and remaining person don't know the secret, then in that case, the ultimate source of parent for P1, P2, P7 will be 0, and for remaining, it will be itself. Like for P3, it will be 3, P4, it will be 4, like that. So we can iterate the array and we can see if the ultimate source of parent is 0, that means that person knows the secret. If it is not 0, that means that person don't know the secret. I hope I have made the solution clear. Let's try to code. So we have discussed like we will create a disjoint set to store that information. So we will create a class and we will create a parent, or we can say ultimate source. So to be familiar with disjoint, I will keep it parent. Now I will keep it public. So now, as we have discussed, the ultimate parent for initially the person will be itself. So we have marked parent of I as I. Now we will have a function of find parent, and it will take a value and we will find the parent. So if parent of itself, parent of you, it's itself, that means we have reached the ultimate parent and we will return that value. Else we will update the ultimate parent of each person. Now we have seen that we have to reset the parent also if there is no meeting between a person who knows a secret and a person who don't know the secret, then we have to revert back the parents we have updated. In that case, we will update the parent of you with you. Now we will do a union by zero. Instead of rank, this time we will do a union by zero. That means we will see if the parent, ultimate parent, is zero or not. If the ultimate parent will be zero, then we will mark the parent as zero. We will first find the ultimate parent of PU and ultimate parent of PV. Now, if the ultimate parents are same, that means both are in same group. We will do nothing. And if they are not same and either of it is zero, that means there is a meeting between a person you who knows the secret and the person V who don't know the secret. So in that case, we will mark the parent of PV to PU. Else if PV is zero, ultimate parent of V is zero, that means V also knows the secret and there is a meeting between V and U. That means now you will also know the secret and the ultimate parent of U will now be also zero. That means parent of U will also be 0. Else, if none of the ultimate parent is 0, then we can make any of the person as parent. That means there is a meeting between you and V, but neither you knows the secret nor V knows the secret. So this will be our disjoint set. Now, since we have to iterate the meetings according to their time frame, so we will sort the meetings based on the time frame in ascending order. So we will use a compare function because we want to compare the meetings with the time frame value, that is index 2. So we will write a compare function who will take a vector and it will return if a of 2 is less than 2, that means it is correct, else it will return false. Now, after sorting the vector, we will create a disjoint set of size, suppose disjoint set D of size n. That means we have n people, so we will create a disjoint set of n. Now, since 0 knows the meeting and 0 knows the secret and 0 passed the secret to first person, so we will do a union and union by 0 between 0 and first person. Now, both 0 and first person will be in the same group. So, since we have to iterate the meetings of a time frame of one time frame, we have to iterate all the meetings of one time frame at once, and we have to check all the meetings lies in us have a meeting, or there is any intersection of that meetings with any of the person who knows the secret. So, so we will find out the current time of the meetings. That means we will find out the time frame. So C time will store the current time frame, and we will store the starting position of this time frame. Now, while I is less than and meetings of I to 2 is equal to current time. So what we will do? We will do a union by 0 of a union by 0 of person at index 0 and a person at index 1. And we will increment the counter, the pointer. Now, so there can be a scenario that we have updated the ultimate source of secret for a particular group. Suppose after this operation, there might be we may have formed a group who have a meeting connectivities somehow, like A to B we have a meeting, B to C we have a meeting, and C to D we have a meeting. In that case, we have might have updated the ultimate source of B to A, and ultimate source of C to A, and ultimate source of D to A. And there is no meeting between this person and a person who knows a secret. That means we have wrongly updated this. So, if that is the case, that means the ultimate source of parent will not be 0. If that is so, then we will revert back this ultimate parent of this person. So, for that, we will reiterate this while j is less than I, and we will check if this ultimate parent is 0 or not. D dot find parent of this person if it is not equal to 0. That means we have wrongly updated and we have to reset the parent. So we will reset. We will call d dot reset parent, and we will pass thing of c 0. Same, we will check for a person at index 1. So, so for person at index 0, we have checked if it is not equal to 0. That means this person don't know the secret, and we have to update the ultimate parent. So we have updated, and in and the person at index 1 also we have updated. So we will increment the pointer. Now, after these operations are done, we have visited and we are at end of the time frames, then we will create a vector of secret. A person who knows all the secret will be kept inside this vector. Now we will iterate the person from I equal to 0, I less than n, I plus plus. And we will see if ultimate parent of this person's I is 0. That means this person knows the secret. We will push the person inside this vector. Now, at the end, we will return the secret. Let's try to submit the test cases. There is some non-void function error. Let's see. Okay. So since we are not returning anything, it will be void. Let's try to submit again. V dot reset parent. I think I have done some typo mistake. Okay, it will be capital P. Let's try to resubmit. Yeah, now the test cases has been passed. Let's try to submit the solution. So the solution has been accepted. So there are other solutions also we can use by creating a graph also. So you may find different approach for this question. Meet you in the next video. Thank you.